Hey guys, we have been given two explicit formulas and we want to find the recursive formula that applies to the same sequence in each of these cases. Now, as I'm going through this, I'm going to assume you're pretty familiar with these explicit and recursive formulas. If that's not the case, totally fine. I'm just going to refer you to a video in the corner that you'll probably want to watch first so that this makes a bit more sense. Okay, so this explicit formula is meant to help me figure out a sequence. So I'm just going to find a few of the numbers in the sequence. So I'm going to find the first number in the sequence, n equals 1. Let's find the second and the third. Why not? So we're going to find the first three numbers in this sequence. So a sub 1, or the first number in this sequence, is going to be equal to 3 times -3 to the power of n minus 1. Now, n is, we're plugging in 1, so 1 minus 1 gives me 0, right? Now, anything to the power of 0 is 1, and if you're like, what the heck, why? I'll link a video for you in the corner that explains why. So this just ends up being 3 times 1, or 3, right? So a sub 1, or the first number in my sequence, is 3. Woohoo! Let's find the second number now. A sub 2 is going to be equal to 3 times -3 to the power of n minus 1. We're plugging in 2 for n, so 2 minus 1 is 1. And -3 to the first power is just -3. So we've got 3 times -3, which would give me -9. So the next number in my sequence is -9. Let's go ahead and find one more. Let's find the third number in this sequence. So a sub 3 is going to be equal to 3 times -3 to the power of 3 minus 1, which would give me 2. So then I have 3 times, this has a lot of 3's in it, -3 squared would give me a positive 9. And 3 times 9 would give me 27. All right, as you do these more and more, you're probably going to pick up on the pattern, right? We're multiplying by a -3 each time. Would you agree? So I could even find more of these now. The next one would be 27 times a -3, which would be -81. And of course, I could keep going if I want to. All right, but I'm not too concerned about finding more numbers in this sequence. What I do want to find is the recursive formula. All right, so the recursive formula is different than the explicit because with the recursive formula, you need to know the number before. With my explicit formula, I can just plug in, oh, I want to know the 100th term and find it. But with the recursive, I have to know the number before it. So how we write this is a sub n, or whatever number you want to find, is equal to the number before it. In math language, we would say a sub n minus 1. If I wanted to find the fifth number in this sequence, I would need the fourth number, which would be 5 minus 1, right? So whatever number you want to find, you take the one before it. And in this case, what are we doing? We are multiplying by -3. That is my recursive formula. Now, in order for this to be helpful to anybody that needs to use it, I need to let them know what the first number in the sequence is, which in this case, it is 3. There we go. We found it. All right, let's do it one more time to solidify that, because why wouldn't we want to? So again, let's find the first three numbers. That'll help us establish the pattern. So the first number, a sub 1, is equal to 3,125 times 1/5 to the n minus 1 power. 1 minus 1 is 0. Anything to the power of 0 is 1. So I'm just left with 3,125. So the first number in my sequence is 3,125. Now, as you do these more and more, you're probably going to pick up on these patterns. Like maybe you were like, oh, I could have told you that was going to be the first number without going through all of that work. As you do it more and more, you'll probably get to that point, which is great. Now, let's figure out the second number. A sub 2 is going to be 3,125 times 1/5 to the first power, which is just 1/5, right? So we're taking 3,125, timesing it by 1/5, which you can also think of as dividing by 5. That's the same thing. So 3,125 times 1/5 or divided by 5 is, sorry, just nudged that paper, 625. So that is the second number. The third number is 3,125 times 1/5 to the power of n minus 1. So 3 minus 1, which would be 2. Okay, so we are squaring that 1/5. So 1/5 times 1/5 would give me 1/25. And we're multiplying that by 3,125. Okay, and when I put that in my calculator, I end up with 125. Okay, so that is the third number. And you may have figured it out. What we're doing each time is you could either think of it as dividing by 5 each time or multiplying by 1/5 each time. Same thing. So if I want to write this as a recursive formula, I would say a sub n, or whatever number you want to find, take the number before it, a sub n minus 1. And what we're doing in this case is multiplying by 1/5. That is my recursive formula. And for this to be helpful to anybody wanting to use it, we need to list what the first term is, which it is 3,125. All right, I hope that made sense. If you need some other videos, I will link a whole playlist for you. Thanks.